33rd example, and what is said in this example: consider a head-on collision between two particles of masses m1 and m2. Okay, so this is m1 and m2. The initial speeds of the particle is u1 and u2, and it is in the same direction. The collision starts at t equal to 0 and it interacts for delta t time. Okay, during the collision the speed of the first particle varies with time as. We have to find the speed of second particle. So as we know that in collision, total momentum of the system initial must be equal to the total momentum of the system final. So the initial momentum is m1 u1 plus m2 u2, as they are in the same direction, so we can directly add them, their magnitudes. While m1 into the momentum of first particle is varying with time, while momentum of second particle, how it varies with time, that we have to find this one. So I will send it on this side. So m1 u1 plus m2 u2 minus m1 into the velocity of second particle as a function of time, m2 v2 as a function of time. So m1 u1 plus m2 u2 minus m1 in bracket u1 plus t upon delta t in bracket v1 minus u1 is equal to m2 into velocity of second particle as a function of time. So m1 u1 plus m2 u2 as it is, I will open this bracket by multiplying with m1. So it will be m1 u1 plus minus will become minus m1 t upon delta t v1 minus u1 is equal to m2 into velocity as a function of time. The positive m1 u1 and negative m1 u1 will get cancelled out. We have to find velocity as a function of time for second particle, so I will divide this m2 here. So it will be m2 u2 minus m1 t upon delta t in bracket v1 minus u1, and this whole is divided by 1 upon m2 is equal to the velocity of second particle as a function of time. So I can write it here for last step. The velocity as a function of time will be equal to this 1 upon m2 will get multiplied inside, and m2 will get cancelled, it will be u2 minus m1 upon m2 t upon delta t in bracket v1 minus u1, and this is the final answer to this question. Thank you.